Today we'll be talking about power and conservation of energy. Power is basically just the rate at which you do work, or how fast energy is being used. It's obtained by dividing the work per unit of time. So it's really the rate at which work is done, or the rate at which you use energy. So what are the units? In the SI system, it would be joules per second, or what we define as a watt. Why is it joule per second? Because work is measured in joules and time is measured in seconds, so it's a joule per second. There are other units as well. For example, horsepower or foot-pounds per second. They're all equivalent to watts as well through this conversion shown here. 1 horsepower is equal to 550 foot-pounds per second, which is equal to about 746 watts. All right, so let's try a problem. You have a 1.5 kilogram toy. It's pushed across the floor with a force of 8 newtons, a distance of 3 meters, and a time of 2.0 seconds. And we're going to assume the toy was pushed in the same direction as it moved, not at any angle or anything. So what we want to know is what was the work done on the car and what was the power used. It's a pretty simple calculation. To figure out the work, you just do work is equal to force times distance. And since the force was in the direction of motion, we just have a cosine of 0 degrees, which is 1. So it's 8 times 1 times 3, or 24. 24 Newton meters, or 24 joules. So that's how much work was done. How much power was utilized? You would just take that work divided by the time. Now that power is an average power. Okay, so that comes out to be 12 watts. All right. There's another way of looking at power as well. It's how fast you apply force to an object. For example, power is a work. We know power is work per unit time. So here's the equation. Power is work per unit time. But we also know that work is force times distance. So we can replace work with force times distance. And we also know that speed is distance over time. So we can replace the distance per unit time right here, distance per unit time, with velocity. So another way of saying is power is equal to force times velocity. And you could also do equations like that as well. So power is a pretty simple concept. Once you understand work and energy, all you have to really do is divide it by time to get power. All right, one last topic. We've talked about conservation of mechanical energy in the prior lectures, but one thing I need to explain to you is that energy itself can never be created nor destroyed. Even when there's friction, the energy doesn't go away. It just turns into forms that we may not be able to utilize. So like with the roller coaster problems we were talking about in previous lectures, they were talking about losing energy. What they were losing is mechanical energy. They didn't ever lose energy in and of itself. It was just created to heat energy or sound, which couldn't really be used by the roller coaster. Another example would be you're in a car and you go 60 miles an hour and you jam on the brakes. The energy just doesn't go away. It goes into heat energy. It's never really destroyed. It just turns into forms that we really can't utilize. Okay? And that's pretty much it.